At first, they were just low-flying barrels, which gradually evolved into flying tanks. Then it even started to resemble a rocket, but it still crashed as soon as it took off. And so, on March 14, 2024, the largest rocket in human history went on its first successful space flight. Yes, Starship couldn't return, but in reality, this wasn't just an ordinary test. It was the beginning of a new space era. And here's why. Fundamentally, new rockets very rarely fly successfully on their first try. Sergei Korolyov's R-7 also couldn't fly properly in its first 3 attempts, but it mostly worked as intended on the 4th try, just like with Korolyov. With each flight, there was a clear positive trend. Problems were being discovered at later and later stages of the flight. The parallels with the historic 4th launch of the R-7 are not accidental. In the 1950s, the Soviet rocket changed the entire world with the Sputnik shock, and by showing that atomic weapons in the era of such ballistic missiles had truly become global and practically unstoppable. This immediately triggered 2 very rapid races, the space race and the intercontinental ballistic missile race. Starship, unlike the R-7, has fundamental features that make the new race it is launching practically unstoppable. Regardless of the will and wishes of countries like the United States, Russia, or China, there's no turning back this time. What exactly are we talking about? At first glance, Starship is just a huge water tower, 119 meters tall, 9 meters in diameter, and weighing 5,000 tons. Of that, about 4,600 tons is fuel, 300 tons is the dry mass of the stages, and the payload in the first phase is supposed to reach 100 tons. In reality, the design of the rocket for a flight to Mars is a bit more complicated than just a flying barrel of fuel. And we've already made a separate episode about this, which complements what you'll see here, just like methane complements oxygen in cryogenic fuel. How are starships assembled? What's inside and outside of them? All of this is in a private Telegram channel that's only available by subscription. There will be truly exclusive content there. For example, in just a few days, there will be a special episode about illegal boxing among Irish travelers, the same one everyone saw in the movie Snatch. We initially created this content for a video on gypsies, but ultimately excluded it due to the footage being too graphic for YouTube's standards. In short, you'll definitely find it interesting. New formats, communication, unique content, and for us, it will be a sign that you support our work. That's exactly what motivates us to keep going. The link will be below this episode and in our Telegram channel. Let's continue. Until now, the heaviest rocket in history was von Braun's Saturn V, which didn't even reach 3,000 tons. Starship is not only 2,000 tons heavier, but it's also designed to be fully reusable. By the mid-2020s, Elon Musk expects to be launching Starship. Enough times so that one of its flights would cost $10 million, and in the future, just $5 million. Even without looking to the future, 100 tons for $10 million means $100 per kilogram of cargo delivered to orbit. For comparison, Protons, the previous champions in terms of low-cost space flights, have figures around $3,000 per kilogram, which is 30 times worse. Besides these dry numbers, there are concrete consequences, for example, the end of the Russian Super Heavy rocket for flights to the moon. Vladimir Putin, on April 12, 2023, instructed the head of Roscosmos, Yuri Borisov, to begin developing a Super Heavy rocket for flights to the moon starting in 2024. The development is planned to be completed in 8 to 10 years, in 2032-2034. However, the development of this rocket lost its purpose even before it actually began. Here is a quote from Yuri Borisov, the head of Roscosmos. I'll say something heretical. This is my personal point of view. Just like with the multi-satellite constellation like Starlink, we kind of missed the start of the renewed interest in the moon. Both America and China are ahead of us in this area. To fly to the moon and talk about serious expansion in this direction, you need to have a super heavy launch vehicle. And we don't have one. The fact is, from a technical point of view, a Saturn V-type rocket is reasonable and sufficient for a flight to the moon. That is, comparable to Starship in terms of payload, but expendable and therefore lighter, somewhere around 3,000 tons. The idea of creating a reusable, specialized lunar super-heavy rocket is more than questionable. Any new rocket requires specialized launch facilities that are suitable only for it. Let's imagine that we've built such a separate launch pad at the Vostochny Cosmodrome by the year 2032. Suddenly, flights to the moon may be infrequent, occurring once a year or even less often. Then, we'll end up with a very expensive and heavy reusable rocket that took 10 years to build, but has nowhere to fly with such a low frequency. In order to pay off the launch facility within a reasonable time frame, the more flights a particular rocket has, the faster it recoups the costs of its development. And the launch pad. The fewer flights, the slower this happens. The shuttles are a prime example of this type of failure. Their economics were calculated based on several dozen launches per year, but in reality, they made fewer than 5 launches per year. Naturally, each individual launch sharply exceeded the estimated cost and reached $1.5 billion, which is dozens of times higher than planned. The main problem with the future Russian super heavy rocket is that, compared to a universal spacecraft, creating a highly specialized rocket would simply be pointless. It will inevitably be much more expensive to use than a mass-produced system designed both for launching satellites into orbit and for missions to Mars. It turns out that the very idea of a domestic rocket specifically for flights to the moon has already become truly outdated because of today's launch. In 2024, Roscosmos will either start designing an equivalent under the guise of a lunar super heavy rocket, meaning a universal super heavy launch vehicle that will replace all the others, or what they will build by 2032. It will turn out to be simply unnecessary for anyone, too expensive and too specialized, like the shuttles. Moreover, Starship makes the prospects of not only specialized lunar super heavy rockets unclear, but also specialized orbital stations like the International Space Station. In April 2023, the first Deputy General Director of Roscosmos, Andrei Elchaninov, estimated the complete construction of the Russian orbital station at more than 600 billion rubles. Of that, 350 billion is for the initial stage. In comparable units, this amounts to more than $7.4 billion, respectively. The developers of the station of the future position it as a big step forward compared to the Russian segment of the International Space Station. After all, the pressurized volume of the Russian orbital station is 450 cubic meters, which is twice as large as the Russian part of the station today. And it's even 20% larger than the volume of the Mir station. And the larger the volume, the more scientific equipment can be placed inside it. Specifically, there will be so much space on the new station that they even plan to test an orbital centrifuge for cosmonauts there. It's a very important issue. Contrary to the widely publicized threat of space radiation in the media, which is actually quite moderate, the lack of gravity can really kill cosmonauts during a long enough stay in space, because our muscles and bones catastrophically degrade in zero gravity. So, a large orbital station is great. Well, let's compare. The cost of one is planned to be around $200 million, and the cost of one flight into space is less than $10 million. Already at the first stage, the pressurized volume is 1,000 cubic meters, which is more than twice that of the Russian orbital station, and more than that of the International Space Station. But it's not just about the volume. A space station in orbit is a collection of cramped modules with an internal diameter of no more than 4 meters. It would be very difficult to fit a decently sized centrifuge in there. And if a centrifuge for space has too small a radius, then when it spins quickly, a person inside might start to feel nauseous and have problems with their vestibular system. Centrifuge. The CF-18 at the Gagarin Cosmonaut Training Center has a rotation radius of 16 meters. At that size, the effect of Coriolis acceleration on the vestibular system is already insignificant, and it feels to a person as if they are flying in a straight line. But with small centrifuge radii to fit into the 3 to 4 meters of internal compartments of a classic orbital station, it might not be very effective. There are also more fantastic ideas, for example, connecting starships into a ring to create that very effect of artificial gravity. In fact, National Aeronautics and Space Administration played with this idea at one time. They considered using the main hydrogen tank of the shuttle, that orange thing on which the shuttle was launched into space. But considering the problems with the shuttles, it all remained just an idea. But even if we don't take into account that ring made of starships, the internal diameter of the ship is over 8 meters, so you can easily fit even the largest equipment for any scientific experiments. Or, if you want, you can turn the entire ship into a giant centrifuge. The engines are actually powerful enough to quickly spin the entire 50-meter ship, and then, when needed, stop its rotation. The same goes for its capacity for people. Classic stations can accommodate several cosmonauts, while Starship, in terms of size and load, is suitable for 40 cosmonauts to live in for a long time. The scientific potential of a station, where besides cosmonauts who conduct experiments according to assignments, there is no place to accommodate scientists, is much less than that of a base, where you can bring both professional cosmonauts and specialized scientists. You will get an orbital station with multi-year life support systems developed together with the spacecraft, a station that is many times more spacious, capable of carrying more cargo, and more comfortable, which will always have the possibility of refueling in orbit and subsequent descent to Earth. To aid, Kate, if suddenly the next stage of upgrading such a station requires some work that will be difficult to perform in orbit, but let's move away from the orbit of our planet and fly further. The first destination in the deep space program is the Moon. Officially, the program plans to land astronauts there as early as 2026. But Elon Musk himself, the key developer of the new spacecraft, does not consider colonizing Earth's satellite to be meaningful. His logic is simple. Mars can be terraformed to have an Earth-like atmosphere and climate, but the Moon cannot. The Moon has too low gravity, and its days are too long. A 2-week night at -173 degrees, and an equally long day at +127. It's clear that such a celestial body will never have an Earth-like habitable surface. However, Musk wouldn't be Musk if he didn't look for ways to make money from any of his actions. That's why he jumped on the Lunar program bandwagon. And even though the deadlines for this program are obviously unrealistic, because by 2026 they haven't even developed proper spacesuits for the moon landing yet, but participation there is practically inevitable. Specifically, under this program, the following is planned. The National Aeronautics and Space Administration of the United States will launch its Orion spacecraft, which is also developed according to National Aeronautics and Space Administration specifications, on its own rocket costing $1.5 billion. It will deliver several astronauts to the Moon. In orbit around it, the spacecraft will dock with the space version of Starship. Then it will lower the astronauts to the Moon, where they will go out and take a walk. Then it will take off from the Moon with the astronauts and lunar soil. The initial mission will focus on flag planting, exploration, and sample collection. By the time National Aeronautics and Space Administration finally makes the spacesuits and everything else, Starship will already have a decent flight record. That's an important point. Until it has that, National Aeronautics and Space Administration will never risk sending people from Earth on such a ship. However, Musk will build up that record, and quickly. That's clear from the experience with 9.5. The latest modification of the rocket has literally completed hundreds of consecutive launches without any accidents. No rocket in history has demonstrated this level of reliability. Not even the R7 family, let alone the others. Moreover, the impressive 95% statistic was achieved in less than 5 years. The first flight took place in May 2018. As soon as it reaches a similar statistic, we'll have to abandon the rocket and the spacecraft, despite the tens of billions of dollars spent on them. Why? Because Starship will make the cost of a flight to the Moon about $120 million. That's about how much a dozen launches will cost at first. First, the actual space version of Starship, and then a dozen flights of Starship tankers, refueling the lunar Starship with methane and oxygen for reaching our planet's satellite and the return journey. $120 million. That's less than what National Aeronautics and Space Administration currently spends on a single flight to the International Space Station. What will the federal agency choose? A flight to 400 kilometers to low orbit, or for the same money, 400,000 kilometers and a landing on the moon? So, the strategy of both National Aeronautics and Space Administration and Roscosmos will inevitably change after the start of flights on Starship. But there are more interesting things. For Elon Musk himself, a fundamentally uncolonizable moon is not needed, but a colonizable Mars is necessary. At this stage, National Aeronautics and Space Administration and Roscosmos have absolutely no need for manned flights to the Red Planet. It's risky and hard work that only makes sense if you're a certain type of person, like Cortez, Columbus, or their modern counterpart of South African origin. Among the administrators of government space agencies, there have been no such people since Korolev and von Braun left this field. The ultimate goal isn't the moon at all, but providing transportation for a colony on Mars that could terraform it using super greenhouse gases. However, centuries will still pass before people can walk there without spacesuits. Nevertheless, these flights will inevitably force the state space agency to go to Mars. And it's not just for the sake of planting flags. Why? It's important to understand that from the perspective of fuel costs launched from Earth, the flight to the moon and to Mars is quite comparable, because the plan is to return from Mars using local fuel. According to the Sabatier reaction, the plan is to produce methane and oxygen from this water ice and the carbon monoxide, two in the Martian atmosphere. By refueling with them during the year-long stay of the expedition on Mars, it will be possible to take off and return to Earth. From this, it is clear that the additional costs of turning lunar missions into Mars missions are not that great. Both there and there, extravehicular spacesuits are needed, and both there and there, rovers are needed. Drilling and research equipment. The main cost difference between lunar and Martian missions will come from the equipment needed for water electrolysis, which is obtained from ice, and for implementing the Sabatier reaction to produce oxygen-methane fuel. However, such equipment can realistically be created for a few $billion, and it normally operates for a long time. Meanwhile, a standard rover mission on Mars costs National Aeronautics and Space Administration about the same amount, $3 billion. The only difference is that the equipment for producing fuel doesn't have to be sent to the Red Planet on every new mission. This means that the only thing that could prevent Americans from landing on Mars in the 2030s is if Elon Musk's business is taken away from him because his views don't align closely enough with the party line. Such a takeover is certainly possible. In the United States, many people have long been irritated by Musk's audacity to hold opinions that don't align closely enough with the party line. But still, that's a doubtful scenario. You can take the business away from the head, but if you don't destroy him in the process, there's no guarantee he won't move to China, and that will simply push the questions of Mars exploration further into the future, which means after debugging her new ship and getting it ready for a flight to Mars. Somewhere in the early 2030s, they'll have to, albeit reluctantly, get involved in this project by providing astronauts and some equipment for the Martian base. The emergence of new technical means turned the situation upside down. A standard crewed mission to the Red Planet in the 2030s could very well cost several $billion. Of course, if there's as much embezzlement as there was on the project, that number will have to be multiplied several times. But in that case, it will definitely create its own spacesuits, rovers, and so on, and will fly with its own astronauts. So, over long periods of time, 2-year expeditions to the Red Planet will inevitably become cheaper, down to just a few $1 billion per flight. Therefore, their cost will drop below the current crewed program, under which National Aeronautics and Space Administration flies. To the International Space Station, the agency simply won't be able to stop flying to Mars. Neither politicians nor the voters of those politicians will understand it. The American government agency will have to keep flying there anyway, no matter how much tension or rejection this idea causes them today. Regular human flights to the fourth planet will de facto lead to the creation of a base there with a habitable volume greater than the International Space Station. Every starship that lands there will automatically become one. Moreover, by landing several such ships there with a reduced crew, They can later be taken away on a single Starship transporter. Any player, whether Elon Musk, National Aeronautics and Space Administration, or operators of Chinese copies. Starship will begin deploying much larger bases on Mars, suitable for hundreds of people. And all of this is just the minimum scenario. Of course, Musk doesn't need a base for hundreds of people. He wants to create a colony with a population of 1 million on the Red Planet. There is a small chance of success for this idea, although that's a topic for another episode. Let us know if you would be interested in seeing a detailed look at the plans for colonizing Mars, and we'll get to work on it. But let's continue. What does the new flight mean for non-American space players? The previous round of making space flights cheaper, namely the program, showed that lowering their cost creates opportunities for using space that simply didn't exist before. For example, was able to inexpensively deploy thousands of satellites in orbit at once, more than all the other space players on the planet combined. But all of this is just the beginning compared to the opportunities that the new Starship stage of lowering flight costs will create. Now, projects like DSTAR can be launched into space. Its name in English is intentionally similar to Death Star. Thanks to its powerful laser weaponry, such a platform will be able to deflect asteroids, or, if desired, shoot down intercontinental ballistic missiles in the space segments of their trajectory. From just one, it's obvious that both Russia and China will have to develop their own counterparts, regardless of whether they want to or not. Because leaving the United States alone in low Earth orbit with a cheaply assembled Death Star is a game that no one will willingly agree to play. The question isn't whether Beijing and Moscow will copy it, but only when they'll realize that it's inevitable. After realizing the need to copy it, it's very important how much time they'll spend on that copying. Right now, Roscosmos is planning to create Lunar super heavy rockets over a long 8 to 10 years. For comparison, the first work with metal began 6 years ago. Strangely enough, the situation with China looks similar for now. That is, the systems are conceptually similar. There are already attempts to do this, but on a smaller scale, so launching cargo into space will be significantly more costly. In that case, landing on Mars for non-American space players will happen somewhat later than for the United States itself. At the same time, it's hard to rule out the possibility that, taking advantage of a temporary monopoly on flights to the Red Planet, they will start to de facto turn certain parts of the Martian surface into their own property. Any verbal objections from China and Russia won't have any effect here, just as the objections of the Papuans wouldn't have affected James Cook's proclamation of British rule over Australia. No ships, no say. Therefore, both China and Russia will have to start flying to Mars, not just to show we can do it too, but to establish their own bases there. There may be no other way to avoid the rapid Americanization of the fourth planet from the Sun. Let's wrap it up here. We remind you about the additional special video in the private Telegram channel. We look forward to seeing you there. Rate this episode if you found it interesting, and let us know in the comments what you think about Starship. Thank you for watching, and see you in future episodes on our channel.